Good afternoon. So I stay close to the micro. I like to walk a little bit and move while I teach. I hope you can hear me well. In any case, of course, as usual, there are many places free in front here. If you want to advance a little bit, it's up to you. I'm not forcing you, but this is an option. But you can hear me well, correct? Okay, good. So, we are starting a kind of travel together. And,
Chiedo scusa, no, da qui non riesco a sentire io, però forse è meglio se si mette dietro al tavolo, perché purtroppo da qua non riesco a sentire io.
Se parlo così, come va?
Sì, così va.
Ho spostato il microfono, può andare?
Proviamo, sì, proviamo.
Ok, dopo poi mi metto dietro al tavolo.
Ok, va bene, grazie.
Il microfono, va bene. Sorry for the interruption. Okay, there is, first of all, I was talking in Italian to the translator, to the interpreter. You know that there is simultaneous translation in Italian. And so if you are interested in the simultaneous translation in Italian, you have to follow the link, the Zoom link in my website, and you will find a possibility, the opportunity to connect through the Zoom. And if you want, you can put on your headphone and listen in Italian. Something that I hope that you can listen in English. I hope my English is good enough, but if you want to listen in Italian, it's possible. Second thing, I am recording lectures, you know, and I am required to inform you about that. I'll tell you later how to get the recordings, the videos of the lectures, okay? Third information, we have lectures on Monday here from 2:30 to 5:30. It's 3 hours. My plan is to start at 2:45 and then teaching 2 hours up to 2:45, 3:45, 4:15. Break from 4:15 to 4:30 and then last hour from 4:30 to 5:15. If you prefer to make a break every hour and not after the first 2 hours, so if you prefer to make 2 breaks instead of only one, just let me know. Usually I pulled the students in the past and they prefer to do in this way with a break, only one, but of course with a break. And if you have any different preference, just inform me. And of course, you need to take an agreement among you, but just inform me if you have different preferences. Okay, so today I am planning to dedicate the first couple of hours to give you information on the course and the logistic, everything. And then the third hour will be the actual start, okay? You may think that 2 hours for information is a lot, but you will see that I have many things to tell you, okay? And I want to make clear everything from the beginning at the best of my possibility. You, in principle, you don't need to take notes because everything is written down where I tell you, okay? But of course, if you want to take notes, just make yourself comfortable. Just take into account that what I'm telling you, it's written down, and there will be a video recorded of this information, okay? So should be fine. Okay, before I start, can you please, because I need to know you a little bit. Of course, I don't want to make an individual introduction for everybody. I think I can limit my pulling the audience here. Can you please raise your hand if you are enrolled in a degree program in engineering? Raise your hand. Okay, okay. Usually it's the majority, and but I'm very pleased to see that there are students from other degree programs. I think a nice feature of this subject is interdisciplinarity. I'm not saying multidisciplinarity, interdisciplinarity. What is the difference? Multidisciplinarity is when we put several disciplines together, just put together. Interdisciplinarity means that we put several disciplines together and there is an interaction. So this is really what I want to reach here. There is an additional term that you may be interested in learning, which is transdisciplinarity. Transdisciplinarity means interdisciplinarity plus the generation of a new and cross-cutting discipline. So these three terms are quite popular today because you see that at the international level, you may know that there is a push towards multidisciplinarity, interdisciplinarity, transdisciplinarity. And I think this is a really nice opportunity, an opportunity that I would like to pursue, of course, together with you. And based on the definition that I just gave to you, we need to stimulate an interaction which is not only between students, but also between students and the teacher. And it will be my job to try to stimulate this interaction, but beware that I will stimulate you. I will try, okay? I'll tell you later how. Okay, that being said, let me just start with showing to you where you can find written down the information that now I'm going to give you. Just 1 second. So you can see here my website, and I write down sorry, the address, which is here. Let me just okay, let me just check because I saw, okay, there is a registration that is recorded. Okay, this is my the address of the website, and if you type it, you will land here. And under teaching, you will see the second link is lecture notes for science of climate change and climate actions. And this is the page where you can find all the information that you need, okay? Perfect. Now, so you see the title, Science of Climate Change and Climate Actions. And I emphasize the term science. We are talking about the science underlying the study of climate change, the science underlying the design of climate actions. We are not discussing about several other phases of climate change. Climate change is a very complex issue. Complex means also interesting, but it has many, you can look at climate change from many different sides. One side is science, another side may be technology. Okay, so we will talk a little bit about technology, but not much. Because this is really wants to be very interdisciplinary, so it cannot go into the fine details. We are not talking about the politics related to climate change, even if, politics may be a part of science, but actually we don't have neither the time nor the preparation, in my case, to talk about politics. We will talk a little bit, but just a little bit about economics of climate change, which is indeed another interesting issue. We will talk a lot about the scientific basis, the main scientific basis, what we believe are the main scientific basis, which are related to atmospheric science, climate science, Earth system sciences in general, and hydrology, which is, again, a part of Earth system sciences. Earth system sciences are the sciences of the Earth system, and the category includes hydrology, climate science, atmospheric sciences, etc. This is what we are talking about here. It is a subject that is articulated in 24 hours of frontal lecturing, and some of these hours will be dedicated to providing fine details about specific issues. In principle, I should deliver all the lectures myself. Maybe that we host a seminar by somebody. And if I have the opportunity, sometimes we have visiting professors, guests. If we get the opportunity, I would like, if I can, to organize some featured seminars. As you know, there is this is a course with a max of 200 seats. So I know that there are several students in a hypothetical waiting list. I say hypothetical because there is no official waiting list. But I know that there are several students who would like to subscribe and couldn't find the opportunity to do that because the seats were already out, all of them. If you have any colleague, or if you find yourself in this situation, because I know that some students are attending even if they cannot take the exam because they are not registered. Just be aware of the fact that some students may leave, may decide not to attend this subject, and in this case, provided you are still allowed to, it's possible to subscribe. So if you want additional information, just keep into account that unfortunately I'm not governing this process. I don't have any control on the subscriptions, and therefore just ask your student secretariat if you want additional information on this. So what are we talking about in specific? We are talking about climate history. I'm reading here. Advanced techniques for environmental monitoring. So we are talking about environmental monitoring because we need the data about climate change. We will talk about climate physics and modeling. We will talk about climate models. And we will also talk about models of climate-related processes, because in order to take action to mitigate the impact of climate change, we need also to devise strategies, and some of them are dealt with by modeling, not only of climate, but for instance, modeling of the water cycle. We will talk about climate change mitigation and adaptation, and I will define what they are, okay? And we will talk about climate analysis with open data and open software. These are the topics that I would like to discuss with you. We can make changes. If I have any proposal, any attractive proposals by you, we can integrate. Of course, if we want to make changes, I need to check if I am prepared to expand into additional topics, which you may suggest. But what I really would like to invite you to do, if you have any wish, anything that you think it would be interesting to discuss, let me know. I can discuss it, or I can invite somebody else, provided, of course, I have the possibility, but I can check. So let me give you some practical details. And first, before I start, I want to clarify, given that you are an interdisciplinary audience, what is my background? I am a civil engineer. And in particular, I would define myself as an hydrologist, which means a researcher on the water cycle. So this is my main activity. I am a teacher, of course. I am professor here at the University of Bologna since 1998. So teaching is one of my first priorities. The second priority is research. And the third priority, institutionally, because we are required by the ministry to satisfy all of them. The third priority is what we call third mission, which is better said in English as public engagement, which means dissemination to the public and the service to local administration, local, regional, and national administration, etc. So I am making research indeed because I'm required to, and the research is on the water cycle. And if you make research on the water cycle, and I started like 25 years ago, you are required to deal with climate change because climate change is impacting human society mainly through the water cycle. Of course, there are impacts that may seem not related to the water cycle, like hot waves or like wind storms. But actually, every climatic process has some connection with the water cycle. Because if you start from precipitation, movement of masses of air, and also hot waves, forest fires, they are related in some way to the water cycle. Some of these impacts are more directly related to the water cycle, floods, droughts. Other impacts are less related, but still they are. So this is the reason why I got interested in climate change. And I started also making research on climate change, more on adaptation than on mitigation. I will define again what they are, mitigation and adaptation. But let me just say that adaptation means that you accept, in a way, climate change, but devise strategies to mitigate the impact. And this is a typical task of the engineers. Okay, why? Mitigating climate change, softening climate change is more an issue for climate scientists, atmospheric scientists, etc. So this is basically my background. Today, 100% of my time is dedicated to teaching, research, and public engagement. And that's it. I'm not a professional engineer. I don't work as a professional engineer. Not anymore. At the beginning, yeah, I needed that, but now not anymore. Just to clarify what you can expect from me. Okay, so I am indeed not a professional, so I can't deliver experience, expertise in professional activities, which, I mean, they are still very important for climate change impact mitigation. I am supposed to be an expert about science, and this is why I'm teaching science of climate change and not strategy, or let's say not technological solutions. Okay. This is the calendar of the lectures, 8 lectures, and this calendar has been fixed by taking into account my personal commitments and holidays, degree days, etc. So if everything goes smoothly, we should close the course at the end of April, the lectures, okay? Still, I cannot make any exam. I will talk about exams later, but I give you this information because I don't want to forget. I cannot fix any exam before the end of the lectures. I'm sorry for that. I am required to, okay? So I can make many exams, but after June, I think 6, 7. So as soon as the lectures end, I will start with exams. I cannot make exams earlier. I'm sorry for that, but I am required not to make any exception. Okay, I will talk about exams later. Lecture notes or tutorial documents. They are available at the links that you see here on my website. Let me just expand a little bit the font. This is the list of the links where you can find the notes, the lecture notes. And let's try to explore them because I need to give you some information. So for instance, the Earth system, the third one. One second. These notes are in the form of web pages. And why? The reason is that these web pages are evolving. I am making changes every year because we need to. We need because science of climate change is continuously evolving. And I realize, for instance, from last year, I didn't make many changes, but I realize already that I need to make changes because every week we get additional scientific publications, additional data, additional information on climate change. So I really need to make frequent changes, which means that, you know, if I gave the lectures in the form, for instance, of PDF file, it is not very convenient if one has to make several changes. In the form of web pages, it's easier. And I can include links here. Of course, you can include links also in the PDF, but it's much more complicated. And these links are, for instance, let's click on this word here, holistic. If you don't know what it means and you see a link, it's a good idea to click on the link. And 95% of the times you will be redirected to a Wikipedia page, not in this case, sorry, not in this case, where there is a definition. So the links are helpful for you to get additional information. And I think, sorry, I need to go back because, okay, I think they are very useful. I anticipate that these lecture notes are what you need and not anything more to study, to get prepared for your exam. So everything it's asked at the exam is to be found here on these web pages without following the links. So you are not required to follow the links if your aim is to prepare the exam. If your aim is to improve your understanding because there is something that you don't understand, or if your aim is to expand your background and your skills, and I will talk about this later, then the links are a good opportunity. So this is a second reason why I prefer the tutorial in the form of web pages. But if you like the PDF, for instance, because you don't want to depend on a connection, you can save the web pages offline, or you can print the web pages in PDF. Of course, you cannot follow the links anymore, but this is not a big problem because for preparing the exam, you have everything you need, okay? A second question may be why my website instead of another facility that is made available by the university. Of course, we have also university facilities. Another opportunity is Virtuale. It's here. Virtuale is web address is virtuale.unibo.it. I think you know it. And it's the official repository of the university. You can log in with your university credential. Just let me, okay, I'm already logged in. And you see here a link to climate change, a link to Science of Climate Change somewhere. Okay, Science of Climate Change and Climate Actions. And if you go here, you basically find links to my website. So it's completely equivalent. There is something more here. I will tell you later what is the additional information that you can find here. Basically, additional information is self-evaluation tests or surveys on the quality of the teaching, something like that. For instance, the self-evaluation test is important, is an emulator of your exam. So it may be interesting. I will tell you later, okay? On the other hand, in terms of lecture notes, it's a clone. So in terms of lecture notes, I suggest you to refer to my website. So the question may be, why your website, your personal website? Okay, there are many reasons for that. The first reason is that, the main one, is that I am a fan of open everything, open teaching, open science, open data, open information. I think that progress in fighting climate change needs share of information, needs open information, open teaching, open education, open whatever. And I don't like the idea that my lecture notes are confined within a repository with limited access. For instance, if one day, hopefully, you will not be anymore a student of the University of Bologna, hopefully you will be, of course, you will not have access to Virtuale anymore. My website, as long as I survive, should remain accessible. So this is the first reason. And the second reason is that I started with this way of teaching more than 10 years ago. Also, I started more than 10 years ago to make available lectures, videos of my lectures. And 10 years ago, the website of the university was not flexible enough to allow me to share my tutorials. Today, it is still with limited flexibility. The university repository Virtuale is not very flexible. And the reason is that they have security requirements, cyber security requirements that I don't have. Of course, you know, it's a bigger website. My website is small, it's easier to protect it, okay? So this is the reason why I have more flexibility with my website. So I suggest you to refer to here, and it should be reliable, always available, should be fast, etc. And let me go back. So we explore, one thing. At the end of each lecture, not really all of them, but many of them, you will find a PowerPoint that you can download. Like in this case, if you go down, 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 you see download the PowerPoint presentation of this lecture. The PowerPoint is an aid for me to teach, because I cannot teach by using these pages. You understand? It's if one teaches with so much text, it's a problem. Let me check if, okay, the display is correct. So it's an aid for me to teach, but of course the PowerPoint contains less information. So my suggestion is to prepare the exam and in general to prepare yourself on this topic, don't use the PowerPoint. Use the extended version of the lecture, the web page. At least, I mean, if you want to refresh 1 hour before taking the exam, the PowerPoint may be useful just as a summary. But it is, the real purpose is for me to teach. Okay, I hope the concept is clear. So when I said everything you need for passing the exam is written down here, I mean the web page, not the PowerPoint. If you just look at the PowerPoint, you may miss something, okay? Okay, let me go back to the website then. Videos. I am recording the lectures. I am teaching in streaming with simultaneous translation, and the lectures are recorded. The videos will be made available over YouTube and Virtuale. The same video, they are identical. And they are a recording of the screen, basically, and of course of the audio. Why YouTube? For the same reason why I am using an open website. I would like the videos to be accessible by everybody. And therefore, I put them on YouTube. Really, YouTube, I started more than 10 years ago. It didn't have any advertisement. Now, I don't like that it includes some advertisement, even if I don't monetize. Of course, I don't monetize the clicks on my lecture videos, but still, there is a pop-up at the beginning with some advertisement. I'm sorry of that. I'm continuing with YouTube because I still think it's the best solution. And so be patient. It's like 10 seconds that you have to wait for the advertisement. Otherwise, you can go on Virtuale. Okay, Virtuale you will find in the same page here. You see there is the Panopto on the right, and you will find here the videos of the lecture, the links. Okay. Okay. Now, let's talk about the exam. One thing, sorry, because I was thinking to something I was forgetting, I couldn't recollect. In Virtuale, please subscribe as a participant to the course. Subscription is open to everybody, because if you subscribe, you will be alerted if I publish any news. So for instance, yesterday I wrote an email, and today you got the link for the Zoom room, but only the students who are subscribed to the subject. So please subscribe, because if I have a change of plans, a change of schedule, I will alert you in Virtuale by sending a message in the forum, and you will get on your email a forward. So you will get by email in real time anything I post on the forum. Okay, you can also use the forum if you want to ask questions, no problem at all. Just be aware of what a forum is, which is something accessible by all the students who subscribed. The subscription is free, so in principle any student can subscribe. Just be aware of that. It's not a private message. If you want to send a private message, you will send an email, and I'll tell you later what my email address is. Exam, this is an important detail. The exam will be through a quiz. Okay, this is something that at the beginning I decided with the students, and we decided to adopt this way, the solution. And it is convenient mainly for you because it makes the exam very quick. Within 1 hour, 1 hour and 30 minutes at most, you get free. And it is, of course, with so many students, it's an advantage for you, because otherwise, especially in the first exams, there is a long queue, and if you had to wait your turn, it's maybe a long waiting. So the quiz will have a duration of 30 minutes with 30 questions. The questions, I already mentioned that any question is related to something that you can find on the web page. You will not find anything strange. Maybe you will find something worded in a different way, but the information that you need to reply is in the web pages. The questions are closed answer questions, and there is no penalty. There is only one answer correct, no penalty for wrong answers. So if you are in doubt, just try, okay? I will remind you at the beginning of each exam, I will remind you these details. And as I said, 30 questions for 30 minutes. Usually, some of the students complete, the fastest students complete it in 15 minutes. So I'm saying this to inform you that you will have plenty of time to make this exam. Of course, questions, they are diverse. So you will find some questions that take 5 seconds to reply, and questions that may take like a couple of minutes. So there is, of course, a strategy to be followed when completing quizzes, and the strategy is to answer first the easy questions and keep the remaining time for the tougher ones. And you will be able, and I'll remind you later before the exam, you will be able to navigate through questions through a navigation panel. You will be able to flag the questions which look more complicated to you, and you are allowed to revise your answers until the last second. So I try to make yourself completely comfortable. At the end of the 30 minutes, the quiz closes, and then I'll tell you the result. First, to get the max mark, you don't need to reply correctly to all the questions. Okay, there is an allowance of, it depends, because I make a statistical evaluation. The questions are different for each student, of course, and when, as I said, when the allotted time ends, I will tell you the mark. You can accept or decline, or you can think about it, okay? If you accept, the exam is recorded, registered, that's fine. If you decline, you can take the exam at the next round, and there is no limitation. If you decline, if the exam is unsuccessful, I don't record anything, I don't register, sorry, anything. So you can try next time. And you will have several opportunities, and I'll tell you later how many. And if you think about it, it's no problem. I usually give 1 week time at most, because so you have 1 week time to think what you want to do. There is no further step. There is no oral examination. It's just a quiz, okay? So how many rounds we plan? I am planning to schedule 4 exams before the end of July, typically. As soon as lectures end, the next Monday or Tuesday, there is the first one, which is June 10, more or less. I'll tell you the dates later, because I need to book a room with the personal computers to make the quiz. And then another attempt after 2 weeks, so around June 24, 25, 26. Another attempt at I would say, okay, 3 attempts before summer. Sorry, it was not correct. So the first one, June 10. The second one is an indication. The dates have to be fixed. June 25, and the third one, July 15, 3. And then there is another opportunity in September, usually around the mid of September. And then there is an additional opportunity before Christmas, and another one in February, 6. Okay. Please try to stick on the scheduled dates, because in principle, I'm not allowed to make any exam during lecture time. In principle means that it is a strong suggestion, a very convincing suggestion by the university. Please don't make any exam during the lecture time. So if you don't make any exam during the lecture time, these are the opportunities. And but if there is a particular urgency, if I can, because of course we have to manage also the availability of rooms, etc. If I can, my suggestion is contact me, but please don't assume that you can get an individual date for you or something like that, okay? Because you are also many students, so you understand that we need to be a bit rigid for your convenience, because otherwise it becomes a little bit messy. As I said, there is no limitation in the number of attempts, and you just have to be aware of the scheduled dates, because if you don't take the exam in due time, especially if you have to subscribe for your final examination, final degree, etc., you have some requirements, formal requirements. You need to finish your exam by a certain date. So beware of these requirements and beware of my schedule, because I cannot grant any additional flexibility beyond the 6 opportunities that I give to you. Okay, individual clarification, no problem at all. If you need individual clarification, individual colloquiums, or if there are some topics that, you believe that you need additional explanation, the best thing is if you ask in the room the questions. This is the best thing for many reasons, because so the other students can take a benefit from it, and also it's the best solution, because in this way you also gain you get accustomed to talking even when other people can listen. And it's an indication also for me that I need to be clearer on some topics. But for some reason, because you are shy or you get nervous, I know that I had also this morning a student telling me, sorry, I didn't ask the question during the class because I feel like embarrassed. Okay, that's fine. And you can ask questions also after the closure of the lecture. You can come here. Usually I stay for at least 10 minutes. So you can come here and I can reply to your questions. Or you can send an email and I give you an appointment online and you can ask the questions. I can also receive you in physical presence. I don't have any problem, as you like. Okay. Finally, in the past, physical attendance of this subject was compulsory, was required for at least 70% of the lectures. This requirement is no more there. So you can attend in physical presence, you can attend online, you can not attend, and it doesn't make any difference on my side for your final examination. But on the other hand, I really wish that you know that I like if you are attending in physical presence or if you are attending online. I like to interact with the students. This is one of the nice parts of my job. So I really like an interaction with the students. It stimulates me a lot. And even if you don't speak, just looking at your faces, I understand if I am on the correct track. I understand if you are interested. I understand many things. So really, if you attend in physical presence or even online, I like it. On the other hand, don't be afraid. If you have other commitments, if you have clashes, if you have whatever, you can, for sure, even not to attend, look at the videos if you feel that you need them, and look at just the web pages. That's fine for preparing your exam. There is another recommendation that I want to give to you. And one thing is to get prepared for the exam. Another thing is to get an expertise in the topic. It's a difference. There is a difference. To prepare for the exam, you need a kind of preparation that needs to look at the fine details. And of course, if you look at the fine details, you don't remember everything forever. Something you forget relatively quickly. And it is an apparent forgetting because it's not a real forgetting, but still, you don't remember the fine details or the math for a long time. Getting your background, getting a skill on the subject instead requires less details, but requires getting a wider vision, a bigger picture. So interdisciplinarity becomes important. And therefore, it's a different way of studying. What I suggest to you is, of course, the market exam is important. We don't have to give low priority to the mark. It's an extremely important thing. And I am very happy if you get a good mark. On the other hand, don't forget, if you are interested in this topic, but even if you I would like to refer also in general to the topics that you are studying. Remember that your target must be to become an expert in something that you like. Becoming an expert means getting this wide vision I mentioned to you earlier. Means that you expand, that you follow your heart, you follow your interest. So if you see a link that looks interesting, if you want to broaden your vision, it's not necessary that you follow the link, you open the link to prepare the exam, but it may give you an additional skill, an additional information, an additional expertise. Look, expertise is not proportional to age. Expertise is proportional to your time, efforts in studying. So when we say an expert may be a very young person. It's a person that dedicated a lot of efforts to studying, getting the big picture. And therefore, if you are interested in a topic. Just try to get to be the expert. And this is important because really, to find a job, it's not the mark, it's not the final mark of the degree that matters. And I would say to find a nice job, an interesting job, it's not the mark of the degree that matters. Of course, it matters a little, but only a little. Of course, if you get a final mark of 66, which is the minimum, of course, who hires you, potentially is interested in hiring you, looks at the mark and says, there must be a reason. But if the mark is 105 instead of 110, doesn't make any difference. What makes the real difference is the interview that today anybody that wants to hire you makes. And we make interviews for everything. Why? Because with respect to the past, now there is less spread in the degree marks. There is less spread. The degree marks are concentrated in a small range because the students are becoming better, because the technology is better, because the information is better, is improved. The way to get the information is improved. Studying today is relatively easier than studying 30 years ago in terms of getting the information. And therefore, how can employers test the candidates? Not only with the mark, but rather with an interview. And during an interview, to perform well during an interview means it doesn't matter if you are nervous. Who is making interviews knows that some people are nervous during an interview, and this is not a problem generally for them. The problem is to get, if you are the expert, if you are a motivated person, if you have an interest, if you are really enthusiastic about the job, this makes a difference. And you have to prepare yourself starting now. Don't delay, because it's a long process to get the expertise, to get, not very long, but it takes time. It's not something that you can say, okay, after the degree, when I have to find a job, I will try to improve my performances in something. No, you have to start now. Not necessarily with the subject, maybe that you are not very interested in climate change, that's fine. And then, of course, you cannot become the expert in everybody then, but you will have a subject where your dreams are allocated to. And then with this, you have to expand, okay? This is a general suggestion, but I also like, when I talk to students, to provide advice. It may be useful, it may be not, but I think that it doesn't harm. Okay. Do you have any questions so far? Good. Okay, I think probably I am forgetting something to say, but I think I gave the basic information. One last thing. When the dates of the exam will be communicated, now I needed to wait for the start of the subject to check how many students are there, and I need to book a lab because we need a PC to make the quiz. And I want to book a lab that is large enough. I don't want to, okay, I could also split into, I mean, the exam is quick, so in the same morning I can make 2 rounds, but I book the lab and then I tell you, okay? So give me like a couple of weeks at most. Okay. I think I was quicker than usual with this preliminary info. Ah, sorry, here I see a mistake. The room is, this room is not 2.7B. I will change this, okay? Because they changed the room. And because this is a large one, we needed a large room, so I need to change here. The room is always Aula Magna, this one. It's not ideal, but still, we have this room. Okay, once again, any question? I like getting questions. Okay, let's start. with the first link here. One thing, I told you that what we are talking about. And a final information on something that we will not talk about. We will not talk about climate change attribution. Attribution means discussing the causes of climate change. Okay, a little bit we will talk about it, but not extensively, because it's a subject in itself. We will talk a little bit, by the way, so don't be afraid if you really are interested in the attribution problem. But it is really a subject in itself. So if you want to expand with respect to what I will say, let me know, and let's check together if I can say something more. But it is really a bit complicated. So this is something that we will not inspect much, and we will focus more on the actions and the science of the actions. Okay, let me just now click on the first link. The first link has a different look with respect to the other one that I just showed to you. This is a presentation. It's an interactive presentation. You can play this presentation on your own PC, and you will see that there are some interactive pages, and you can play with them as many times as you want. This is an introduction to the problem, an introduction to what we are discussing. Okay, first of all, what can you see here? Left part, left graph, it's the progress of global warming. You know that one of the most striking evidences of climate change is global temperature. Global temperature is increasing. We know that. And this is called global warming. Keep in mind that climate change is different with respect to global warming. Global warming is a part of climate change, but climate change is much broader, of course. But in a way, we think that global warming is driving the other changes. This is not completely true. This is not completely true, but global warming is indeed a striking evidence. So this is why we usually start from there. It's a striking evidence, as you can see from this graph on the left. What you see here is global temperature in terms of anomaly. Anomaly means that with respect to this time span, you take the average and you display on the graph the differences between the average. And what you can see here is monthly temperature, not annual temperature, monthly temperature. So the graph is a little bit spread. You may have seen other graphs which are smoother because it may be annual temperature, okay? This graph, again, is anomaly. And some students ask me, why don't we display the temperature instead of anomaly? You may find graphs with the temperature. It's not really, it's a matter of, it's a convention. Many graphs, many institutions prefer to display the anomaly with respect to the temperature, but it's just a shift of the graph upward. It doesn't make any other difference. This graph is taken, the left one, from our world in data. Let me click on here. What is our world in data? It's an open repository of, let's say, variables related to sustainability, not only global temperature. There is much more. We will see what you can find there. I think this is extremely interesting for you because these are free data. You can also get the numbers. Here I selected the graph, but you can select table here. You see table, and you can see the, by clicking on the links, you get the numbers. here the graph is updated. The previous one was ending at end of 2022. Here you see it's updated to 2023. So you get real-time information of, in this case, global temperature, and you can take the northern hemisphere. So this is the world. You can plot, let's take the world out. This is the northern hemisphere, and or the southern hemisphere. Look at the difference. It's not easy to see because they overlap, but look at the difference between the northern hemisphere and the southern one. In the southern one, global warming is less pronounced, is less evident. It's there, but not as much. First of all, what does it mean, not as much? How much is global warming? Let's go back to world. So what is the difference between temperature today and temperature in 1880? The difference is about plus 1.3 degrees. Beware of the orders of magnitude. When you go for an interview, the first thing that people want to get from you is to get your skill, your capability to get a good picture of what you are talking about. The order of magnitude is extremely important. If you go for an interview and say global warming is plus 5 degrees, the people say, okay, this person doesn't have an idea of what global warming is. And these are typical questions in an interview. Maybe not directly, but people really want to get your perception of the process, if it is good or not. And so plus 1.3, plus 1, you can say, or plus 1.5, more or less. It's a good indication of the order of magnitude. And it means that you have a good perception of the process. Okay? So it is at the global level plus 1.3. Now, if you go at the northern hemisphere, you will see that it's something more. It's plus 1.5. In the southern hemisphere, it's less than that. It's, okay, if you start from here, is minus 0.2, and here is like plus 0.77, plus 0.8. So it's plus 1 in the southern hemisphere, it's lower. Why? We don't know. We may have some guesses of why. And first of all, we have less thermometers in the southern hemisphere because in the southern hemisphere there is oceans, there are oceans, and most of the oceans are in the southern hemisphere. And the presence of the oceans may be a physical explanation because the oceans may smooth the process a little bit. So maybe that it comes later a little bit because of the presence of the oceans. But actually, we don't have a full comprehension of the climate. So there are still several unknowns and some questions that we can't reply to. Another information, okay, in the world is plus 1.3. Over the Alps is plus 2. It's more than plus 1.3. Why? We don't know. Maybe that the reduction of the snow coverage has increased, amplified the impact of global warming, maybe. There are hotspots. Global warming is not homogeneous. There are hotspots. There are some regions of the world of the Earth, where glaciers are still advancing, while most of the regions, we see a retreat of glaciers. So it's also very important to be aware of the fact that global warming, climate change, is not something homogeneous. It impacts society in a different way, in a diverse set of solutions, of outcomes. Okay, so, I mean, this is quite significant. You see a clear trend. You see that there are still up and downs. Okay, this is fine. We know that climate is not a constant. It's not a straight line. There are up and downs, but we see a clear increasing tendency. Now, let's go back to my website and this presentation. So when this increase happened, first of all, data, measured data, in this case of temperature, refer to the so-called instrumental period. The instrumental period conventionally starts from 1850. Before that date, we don't have enough information to extend the graph back from direct measurements. Direct means thermometers. If we want to go further in the past, we need to refer to the so-called proxy data, like ice drills, like limnology, geology. We need to find proxy data. We will discuss about proxy data, but proxy data are less reliable than measured data. So the so-called instrumental, why instrumental? Because we had an instrument measuring the variable, starts from 1850. And this is interesting because why they didn't measure, okay, temperature is maybe a bit complicated, but they had the means to measure temperature even earlier. Why they didn't do that? There are some environmental variables like rainfall that are very easy to measure. Measuring rainfall is extremely easy. You put outside a tank, every day you go there and you measure the depth of water that is inside the tank, and then you take records. So this is something that people could have done starting from 3,000, 4,000 years ago, but they didn't do that. While they started observing the star, they started studying astronomy, but they didn't start climate. They didn't study climate. Why? We don't know, but probably because they didn't need it. They needed to study astronomy and the stars to get oriented while navigating, while probably they didn't have the need to study climate. There are exceptions. The Egyptians, for instance, collected water level of the Nile River every year for 600 years. And the reason is clear, because they depended on the floods of the Nile River to get the lands fertilized, as we know. We studied that at the secondary school. So when people needed to study climate, they indeed did it. When they needed to monitor climate, they had the means to do that, and they did it. But in the case of, or in this case, in the case of, they didn't do that continuously. So we can't really say if how the climate behaved in the past. We need to refer to proxy data, but we will see that there are limitations. And this is a big problem for us because, I mean, for climate, 200 years are nothing. 200 years seem a long time to us because we compare traditionally with the span of the human life. So we say, I mean, 200 years are a lot. Okay, not really a lot. 3 human lives, one after the other. So it's not really a lot. But still, we think it's a lot. But for climate processes, it's nothing. We know that we had glaciations that lasted for like 10,000 years. So you understand that 200 years is nothing. So we need some information. We miss some information. Let me go again to our world in data, sorry, because I want to draw your attention on the type of information that you can find here. As I said, they are related to sustainability. So if you go to the topics, you see population and demographic change. This is highly related to sustainability, population growth, age structure, gender ratio, life expectancy, etc. Health, alcohol consumption, very interesting, and many other things, energy and environment, food and agriculture, poverty and economic development, education and knowledge, innovation and technological change. So, I mean, it's extremely interesting. Keep it in mind for your information, and maybe that you have to write documents for an internship, for your thesis. This is really interesting. And let's see the population growth. And let's go on the graph. And here, there are some countries you can play, but let's take the world. Let's take the countries off, and let's take the world. The world is here. And this starts from 1950. It's quite interesting. You see, 1950, 2.5 billions. And 2021, almost 8 billions. We know that, but it's amazing. And just out of curiosity, Italy, Just let me take the word off. And here you can see that it's a different story. And you can see the demographic decline for Italy in the past 10 years. Okay. This is something relatively new. Why this is relevant to us? Because sustainability is strictly related to human population. And, here we are. Maybe what we notice is that the increase of human population is, in a way, somehow related to global warming. Remember, the graph of human population started from 1950. So let's look at the graph of global temperature. It's more or less, okay, with up and downs, more or less stable up to 1975-80. Actually, there were periods between 1930 up to 1980 with a decline in temperature. If you search on the web for global cooling, you will find in Wikipedia information of global concern related to the decrease of temperature in after 1950 up to 1980-90. Global warming started from about 1985-90 up to today. And during the same time, if you look at other variables, here you can see global freshwater use over the long run taken by from our World in Data once again. And you see that more or less at the same time, there has been a striking increase of the global freshwater use. This is something positive because, I mean, if you look at other socio-economic variables like the gross domestic product of countries, you see a striking increase of the gross domestic product after the Second World War. And the reason is that after that, we had a relatively a long period of peace, at least in a large part of the world, not everywhere, of course, as we know. And we had a period with a very striking increase of our technological capabilities. And probably the reason was in part also the war, the two world wars. Wars are known to stimulate an increase in technology. Like, for instance, the pandemics stimulated a corresponding increase in technology. We know that. Because from crisis, usually humans react with a positive reaction. And this stimulated a striking increase of several variables related to socioeconomic development, as I said. This is good because it means that at least in a part of the world, not everywhere, we have had an increase in welfare, an increase in life expectation, an increase in public health. We improved public health. So it is indeed good. On the other hand, it raises concerns on sustainability. This is one of the reasons why the global population increased. It's also a reason of increasing prosperity. But on the other hand, is a reason of concern, this increase of prosperity because of sustainability. This is why this increase has been termed the Great Acceleration. The Great Acceleration is a popular term today, indicates an increasing trend in various measures of human activity. Again, it is fine. On the other hand, it is the motivation to be concerned on sustainability. Climate change is strictly related to sustainability. So this explains why we are concerned. But what is climate change? Now let's look at the details. Here there is an interactive slide. Okay. So I'm sorry that you can't see for some reason. Let me see. Okay, you can't see the title, but the title says, what is climate change? Select the most appropriate answer. And so I would like to make a poll just to get a figure of your feeling about climate change. So who is voting for the first option? It's the occurrence of unprecedented extreme events. Raise your hands. Abstention is not allowed. But I anticipate that I will make 2 rounds. Raise your hand if you are convinced that, okay. I think only one, okay, few hands. It's a global deterioration of climate. No hands. It's a global increase of temperature. Is a long-term shift in weather patterns. More hands. Okay. Okay, it's a long-term shift in weather patterns. Okay. This is the definition of climate change, but let's try to be more specific. What does this mean? So what is weather? What is climate at this point? So in order to give you the definition here, there is another game. For instance, let me just write here, climate change. If you click on this answer, you see that there is the green light. Now there is another game, and I'm not asking you to make this game with me. I just say that you can play with it. So how would we define the weather? There are 2 alternatives: day-to-day state of the atmosphere, such as, for instance, day-to-day state of temperature, humidity, rainfall, wind, or the other definition, it's that I would say weather. Weather describes a long-term average of these variables. So we have these 2 alternatives, whether day-to-day or long-term average, and the same for climate. Of course, one of the definition applies to climate, the other definition applies to weather. So weather is day-to-day state. Don't make mistakes. Climate describe the average weather. Okay. So here we should write weather. And here we should write climate. And here weather again. Okay. So be aware of the difference. So when we say, today is very, very warm, mid of February, 17 degrees, this is climate change. No, I'm talking about weather. So one day is not an indication of climate. We need to take an average in order to talk about climate. How long is the time period where I should compute the average? Climatologists say, climate scientists say 30 years, at least. Okay. This means that I cannot say that if I have 1 year, like 2023 was the hottest year on record. Okay. The second one is 2016. I cannot say that 2023 is alone is an indication of climate change. Next year would be like 1 degree less, unlikely, but who knows, could be. And therefore, 1 year doesn't tell anything about climate. Okay, some people say that 5 years, average over 5 years is already an indication, but actually climate scientists say 30 years. There are many reasons why they think that a longer window is more appropriate. What is one of the main reasons for averaging? Let me see if I well remember the content of the next slide. Yes. We need to distinguish change from variability. We need to distinguish change from variability. Here, this animated graph on the left represents temperature, annual temperature, temperature change, sorry, in tropical America and Northern America. You see that in both of the cases, we have an increasing trend, and the magnitude of the trend is more or less the same. But you see that the blue line is much more spread around the mean, while the red line is more, let me say, condensed around the mean. So variability, indeed, it represents how spread or closely clustered the data are. Okay. A lot of variability means that it's more difficult to detect change in the short term. In order to smooth out variability, you need to take an average over the long term. So why climatologists say that we need to average over 30 years? Because they know that the next year, 2024, may be colder, but it is not meaningful 1 year. They want to make sure that we base our evaluation over a longer time period, a long time period, because we need to smooth variability out. Understanding variability of climate is important for mitigation and adaptation to climate change. If we want to minimize the impact of climate change, we have to understand variability of climate. This is why people look at proxy data and try to reconstruct the past climate starting from like 500 million years ago. They look at the past because we want to understand variability. One thing is a tendency that is going to get reverted after maybe also 100 years. One other thing is an irreversible change, something that is going to increase forever. Okay, so it's important to understand variability. And I want to stress it because in a way, the term variability is something that in our feeling, we don't like, because variability means transitional, means temporary. And it may be that if we talk too much about variability, solutions are not taken, because people may think something like, okay, let's just wait. And climate will resolve everything by itself. So it is something that we don't like as a feeling. We don't like the term variability. If people, what is the reason why people say climate change and don't say climate variability? Why the media say climate change and not climate variability? It is because we don't like it. But we are scientists, we are researchers, some of you are engineers, and then our main task is to gain an objective understanding of what's going on. So this is why I'm putting the accent on the fact that even if we don't like to speak too much about variability, we still have to understand it, because it is essential to drive us to find the best solution. Keep in mind one thing: whatever we do to fight climate change, it implies a cost, and this is a social cost. It's not something that is paid by somebody else, it's paid by people. And a social cost means a decrease in diversity, inequality of opportunities, because some people can pay, other people cannot pay. Climate change is a global problem. It means that everyone should contribute, but on the other hand, we have to be aware that if we want to be successful, we should find a way to charge this social cost in an equitable way. And finding the right solution is important to minimize the social cost, to make solutions doable, feasible, and to avoid that this solution increase the poverty, because this is the problem. It is the real problem. Sometimes we think that it's just the will that is lacking to resolve the problem of climate. It's not only the will. In some cases, of course, we have lack of will. But the main problem is the social cost. And the main problem is to make sure that we find equitable solutions. Because if it's not equitable, it's not going to be successful. Okay, because climate change is something that cannot be resolved only in one country. It should be resolved at the global level if we want to be successful. If we want to reduce climate change, it's a global action. But the price should be paid only by those who can pay for it. And this is really a complicated problem. So finding the right solution, understanding climate change is extremely important, because otherwise we don't take any action. And this is what happened until now. I mean, we can't say that we are happy of what we did so far for fighting against climate change. We listen to the media complaining, the people complaining, Friday for Future complaining, because we can't say that we are happy. But this is something that we have to expect if we don't approach the problem in a very informed way. Okay, we talked about variability. Now, another question. A relevant problem, I said just a few minutes ago, we will not talk about attribution, but attribution is a relevant problem. Okay, so what is the cause of climate change? And it is also a relevant problem, not only from a political point of view. If we want to find a solution to a problem, we need to identify the causes of the problem. This is a saying that we engineers usually repeat, like, you have to find the causes, you have to attribute the problem to the correct reason for the problem if you want to find a solution. So indeed, it's important to say, to understand what is the cause of climate change. It's human emissions, yes, but it's only human emission, or there might be something else, okay? So it's a relevant question. And it's a question in itself that requires maybe a full subject in a degree program, because it is really complicated. But I think that complicated, I would say, it's a negative connotation. It's really interesting with the positive connotation. And there is something that we need to know. So some information I would like to give. So 1 year ago, let's say 18 months ago, I was a lecturer at a summer school focusing on climate change. And there were, of course, other teachers. And a very well-known climatologist, climate scientist came, and he's really very, very, very good and intimately convinced that humans have, if not all the responsibility, almost all of it for climate change. And he asked the audience this question, which I found like, why? I mean, it's like something obvious. It's clear that humans are responsible for climate change. On the other hand, I was a little bit hesitant on the reply to give myself. So what is the reply that you would give to this question? So let's raise hands again. So one reason could be that the scientific community agrees that anthropogenic forcing is dominant. Raise your hands if you think this is the reason. Of course, read also the other. He didn't give, he just formulated the question. He didn't give the answers. And I am reporting the answers here because these were the answers that were given by the students. Okay. So raise your hand if you think that consensus in the scientific community is the reason why we are convinced that humans are responsible for climate change. Nobody. Okay. The media agree. Raise your hands if you think that it's the media. Nobody. Climate models cannot explain current climate change unless anthropogenic forces is considered. Some hands. Good. And the global warming is occurring with unprecedented speed. So it is something that never happened before. So it's clear that it's for humans. Raise your hands. Okay, the right answer, as he said it, is this one. So basically, it's not true that what's happening today, because I asked him later, because my favorite answer was unprecedented speed. And I asked him, and he said, no, absolutely. It is in the past, according to proxy data, we had other periods where global warming increased very quick. Temperature changed very quickly, either in increasing or cooling. So it's not really. The reason why we believe it's humans, it's indeed models. So we have models of climate. And these models, unless you put human emissions into them, you can't explain global warming. We are just talking about global warming for now. Let's forget about rainfall, windstorms, etc. Global warming, because it is the most striking effect of climate change. So he said, absolutely, it's not, it's models. And this stimulated into my mind a lot of thoughts, because as an engineer, I was told at the university, but I mean, even during my PhD, I was told several times that an engineer should not blindly rely on models. An engineer can use models, but can use models provided they are rigorously verified. And this is not the case of climate models, unfortunately, because we don't have enough data. Otherwise, if the engineers relies on models that are not rigorously verified, he takes a responsibility. And if something happens, then the engineer has to respond. He's sued and has to respond. And I was told better to use data unless they are available, if they are available, of course. And if they are not available, it means that you cannot verify models. So be very careful in justifying the use of a model on the basis of a convincing evidence. This is what I was told. And indeed, engineers are used to first look at data because they know that if they make a mistake and they have to defend what they have done, showing data and providing evidence that they acted according to data is the ethically correct way of defending our position. So I was really like, okay, I said, now what should I do if I am, as an engineer, called to design a solution, to design something that is supposed to resist against climate change, and that something fails? What should I do? I don't have the answer. I'm just telling you. And actually, I'm called several times by water boards, consultancy. I am required through the university within my third mission. So this is another duty, public engagement, but I am required to offer consultancy to administration, water boards. And actually it happened. And they said, look, I want to get protected against climate change, devise a strategy. And what I did, I'm reporting to you my experience because I still don't have the answer. What I did is to look at climate models. This is the first obvious thing. The data are available, are open, you can download. And I looked at the climate models output in terms of rainfall, because the problem was about protection against droughts. And also I am interested in floods. I am an hydrologist. And actually, the output from climate models for this region was not predicting any change. So I was really puzzled. And I know that models are uncertain, but I couldn't go in front of my client, water board in this case, and say, look, there is no change. This is something that, it's clearly incorrect. So what I did is to look at data. I took the worst water crisis in the past. It was between 1945 and 1950 in Bologna. It was a big water crisis in all the north of Italy. And I said, let's suppose that this happens again. And I still think it is the safest solution that I could adopt. To look at the past, take the worst crisis, long-term crisis, lack of water for 5 years. And I said, let's take this. Let's suppose that it happens again. Climate models, unfortunately, were not able to repeat it. This, I'm telling you to give you an idea of the complexity of the problem. So in this case, I discarded the output from models, and I prefer to stick on data, because this is what, for an engineer, is ethically correct. The problem is complex, and the question is not resolved. I mean, what to do? And keep in mind that if you are excessively conservative, again, the implication is inaction. If you don't have money to pay for activating a strategy, especially in Italy, for the large public debt that we have, this is another problem. If you have money, if the state, the administration, the government has money, it's easier to fight climate change. If the government doesn't have any money, and the public debt of Italy is one of the highest in Europe, this means that if a solution is too costly, there is no solution. So it's indeed a responsibility. It's a complicated problem. It's an interesting problem. I like responsibility. It's interesting, but still, it doesn't help much if you like it or not. It helps a little bit. Okay, let's make a break now. Okay, 15 minutes, and again here for 40 minutes more. Okay, we can restart. Do you have any questions so far? Any critical comment, suggestion? Nothing. Okay, one thing that I will make available in Virtuale is a survey that I would like to offer to you on the quality of teaching. It's anonymous, of course, that I will make available in a couple of weeks. Because as you know, there is a survey of your opinion on the quality of teaching, but it will be later on. And so later on is too late if we want to adjust some details. And I really would like to get your critical feedback. So if I speak too fast, if I speak too slow, if I am too trivial, of course it is, you are a very diverse audience. So it's not easy to meet the expectation of everybody of you. But on the other hand, if you have any different expectation that I'm not meeting, I really appreciate if we can discuss. And you may come individually or we can discuss all together, no problem at all. Any interaction that we may have, I think it helps in improving the quality of the teaching. I'm not soliciting you too much in the first lecture, but I will try to in the future. Okay. Let's move forward. Some numbers, just 1 second, let's try to, some numbers about climate change. So let's start from the left. And first, the graph is not updated because it's updated 1 year ago. And actually, 2023 was the hottest year on record. So it gives relevant information to understand the size of the problem. And the global population is increased from about 2.5 billions in 1950 to about 8 billions today. In this slide, some of these numbers are very useful orders of magnitude and also give an information that you may find in some of the questions at the quiz. For instance, in the quiz you may find a question like how much has increased global temperature since 1880? And you will find different answers, very different from each other. So you will not find 1.3, the correct one, or 1.4. You will find 1.3 or 0.1, 2, 0.5, just to check that you have the big picture available, okay? So global temperature has raised about 1.3. We already discussed this. Temperature increased more in the northern hemisphere. We know this, we discussed already. Sea level rise, this we didn't discuss before. From 1880 to 2020 is about 21 centimeters of global average. 21 centimeters. So please get the order of magnitude. It's the global average because sea level rise is not uniform everywhere. And you may ask why, because we have tides, we have also differences in the ocean topography due to wind pressure. And there are prevailing directions of winds that give a different displacement of sea level, cause a different displacement of sea levels in different regions. And 21 centimeters. So you may find that it's a bit contrasting with the the warnings that sometimes we receive that some islands may disappear in the future, because of course 21 centimeters is not enough to provoke a significant reduction of length, of land extension. On the other hand, the concern is motivated by the fact that we had until now a regular increase of sea level along the progress of global warming, and this increase was a bit limited. We cannot predict the speed of this increase in the future. For instance, it may happen that the ice caps melt suddenly. We had, in the past history of the Earth, we know that, we had already long periods without ice caps. Now we have ice caps, and the reason is that we are in the tail of a glaciation that is extinguishing, but we still have ice caps. So we don't know in the past if ice caps melt slowly or suddenly. And what may be the reason for a sudden melting? The reason is that we discovered a few years ago that in the ice caps, there are lakes of large size embedded into the body of the ice. And the reason is that the high pressure of ice prevents water to freeze. So we have this big lens of water. And we already know that in the recent past, there have been some sudden outbursts of water from the body of the ice caps. And, we don't know in detail what is the extension of these lakes. So it may happen that we get a sudden release of water from one very extended lake that may provoke a sudden increase of sea level. We don't have enough information to predict if this is likely to happen. And people are now installing cameras because they aim to film, to record on a video one of these outbursts, which would deliver interesting information because they are monitoring environmental variables like temperature, like humidity. And if they could associate one of these events, one of these outbursts to these temperatures, to these variables, we could make a prediction. But this is something that we still don't know. So this is the reason why we get warnings. Because we know that if the ice cap melts, the level of the ocean would increase of about, I don't remember, but I think a few meters, some meters. And so you understand, not few, several meters. So you understand that this event is the reason of concern. Global CO2 emissions have raised from about 5 to about 35 billions of metric tons from 1940 to 2020. Global CO2 emissions per capita increased from 2 tons in 1940 to about 4.5 in 2020. CO2 concentration in the atmosphere increased about 25% from 1980 to 2020. This is a striking information. And global economic losses from weather catastrophes are about 300 billions of US dollars, steadily increasing. So remember these numbers, which are, I think, significant. Here you can get a video. Let me click on it and let me just take the voice off. Oh, I think there is no voice, okay. And this is a video from an AS. There is voice. Just one second. I told you that YouTube is putting advertisements, so even an ASA, it's getting them. This is a video of summer temperature from 1900 to today. And I think it is interesting. Okay, you see the picture that is becoming redder and redder. So temperature becoming higher and higher. But what is interesting is to see the location of the hotspot and the fact that they move. They move. So the red parts, this is 2023, the red parts are moving, just 1 second, are moving around the globe. Okay, here it is. Of course, there are zones where you see more frequently hotspots, and this video has been made available just a few days ago because it's also showing the situation in 2023. And what is interesting again is the variability of these hot locations. Okay, let's go back here. And let's move forward with just 1 second. Negative impacts of climate change. And let's talk about global warming with more details. We already talked about it, but let's look at it. So basically, you see the pace of global warming is fluctuating, but the general tendency, this is annual temperature, it's not monthly data. You see that the general tendency is to an increase with fluctuating pace, but still it's an increase. So from National Geographic, we read the sentence that you see in bold here: Earth is warming up and humans are at least partially to blame. From National Geographic. The causes, effects, and complexities of global warming are important to understand so that we can fight for the health of our planet. This is what I said before. We need to understand the reasons, the causes. Global warming impacts the environment, changes the seasonality of several natural processes. This is something that is usually forgotten, the change in seasonality. So anticipation of snowmelt, this is a big issue. I will give you more details. And has potentially negative impact on the global health. This year, last semester, I taught for the first time at the Faculty of Medicine a series of lectures titled Climate Change and Global Health, to focus on the impact on health of global warming and climate change in general. And one of the main impact is the mental disorder that climate change is triggering in several cases, and in particular in specific locations where it is most impacting. Global warming is not uniform, we already talked about it, and there is a significant impact on the agricultural practices, water resources dynamics, and management. You know most of these considerations. I just want to stress that seasonality is something that is not completely known. I want to give you an example. The Po River is essential for water resources management in the north of Italy. In the Po River catchment, it is produced about 60% of the Italian gross domestic products. So there are significant water demands for civil use, industrial use, agricultural use. And a large part of this water is taken from the Po River or from groundwater that is recharged by the Po River. So the dynamics of the river regime in the Po River is essential for the sustainability of the socioeconomic sustainability of the north of Italy. Now, you know that the Po River is experiencing with higher frequency droughts during summer. So we made a study to investigate what are the reasons. And what we found is something that may look obvious, but it is nevertheless, in my opinion, interesting. What we found is that the annual average of the Po River flow is not changing. There is no significant change. So we said, okay, but if there is no change in the annual average and there is an increased frequency of low flows in summer, then I should find somewhere an increase of flow. Somewhere means not in summer. And what we found is indeed that the spring flow is increasing. Why? Because there is less snow, more rain, and anticipated snowmelt for global warming. And this is causing a change in seasonality of the river flows. So even if it rains more or less the same, it rains a little bit less, but not much less. Even if it rains more or less the same, we have in summer less water. And this is indeed a problem. Okay. Now, again, on the negative impact of climate change, weather extremes. So we talked about global warming, let's talk about weather extremes. Climate models show that weather extremes may become worse after global warming. In particular, climate models predict that we have more intense precipitation. Precipitation intensity is going to increase. And periods of low precipitation seem to be more frequent. This means that average precipitation is more or less the same, more or less. But we have more rain in restricted time windows. This is what climate models are indicating. Actually, if we look at the data that we have, it's not so evident, this change. But the problem is that we don't have enough data of very short rainfall. We measure typically rainfall daily. Now we try to measure rainfall hourly. But these hourly measurements started only a few years ago, like 30 years ago. And we have very few measurements of very short rainfall, short in time, like 5 minutes. Now, so we cannot say that data contradict what models say. On the other hand, we cannot verify the models, but our perception is that certain type of floods are more frequent. What type of flood is more frequent? The small-scale floods. Look at the Italian context. We are not getting, in the past 20 years, flood from the Po River, from the Arno River, from the Tevere. Okay, some periods of high flows, but not floods. While we are getting floods from small creeks, small torrents. Remember, it's a basic principle of hydrology. If a river is fed by a large watershed, a large river basin, like the Po River, all the north of Italy, almost all of it, with respect to a river that is fed by a very small area, like few square kilometers, the difference is that the flood in the small creek river is caused by a very intensive precipitation that falls in a short time, like 5 minutes, like half an hour. The Po River, the floods in the Po River are caused by precipitation, by rain that lasts for at least 1 week. So the larger the river, the longer the duration of rainfall must be to trigger a flood. So this means that if we see more floods in small basins, we should be concerned by rainfalls that are very short in time. And these rainfall events are hard to measure. So our perception is indeed that this short time rainfall is increased because we see an increase in small scale floods. Okay. So this is a kind of confirmation that what the climate models say may be important. Still, when you look at the output from climate models locally, you may find some contrasting results in terms of rainfall. Climate models are quite reliable for temperature. If you look at rainfall, And in particular, it's not clear if climate models can reproduce well the memory of the process. What does it mean, memory? It means that sometimes we know that in climate, and in particular in rainfall, for reasons that we don't know, there are periods where we get cluster of floods, or sometimes we get droughts that last for 10 years. We don't know why. This means that the process has a memory, in the sense that when a crisis starts, it lasts for a long time. And this kind of event is not well reproduced. The memory is not well reproduced by climate models. And this is particularly concerning for droughts, because we are, of course, concerned by droughts that may last for a long time. These droughts occurred recently in Australia, in California, South Africa, in Greece, and in Italy. The last one was, I already mentioned it to you, was from 1945 to 1950. Okay. We did several studies on short-time rainfall by collecting data all over the world. And first, let me say that the time is short, but not so short. Most of these studies are carried out on daily data of rainfall. And what several researchers found is an increase of daily rainfall of the order of magnitude of about from 6 to max, in few spots, 20%. Which is not so significant. I mean, of course, in some situations, even an increase of a few percentage points may cause a disaster. But actually, usually our protections against flood are measured with a safety factor of are designed with a safety factor of 1.5. So these measures should be able to cope with an increase of 10% of rainfall. Still, of course, this increase was detected, and it's in line with the fact that for every degree of increase of temperature of the atmosphere itself can retain 6–7% more of water. Okay, so I repeat this. From any degree of increase of the temperature of the atmosphere itself can retain about 6–7% more water. And so it is in line, because we had a global warming of 1.3. So in principle, the atmosphere is able to retain about 10% water more. Of course, it depends on whether there is enough evaporation to feed the atmosphere, but provided that we have enough evaporation, we should expect with 10% more water, we could expect 10% more precipitation, at least intensive precipitation. Okay, these are the negative impacts of global warming. Now, floods and droughts. Floods and droughts are caused by weather extremes. So again, negative impacts of climate change, floods and droughts. There is a big difference. They both are related to water, but floods are typically developing over a small spatial scale and a small temporal scale. So a flood doesn't last for years, and a flood, it's normally local, it's not regional. Sometimes it happens that it's regional. If you think of the Romagna region in May, it was a regional flood because they got overflow and they got water from 22 rivers, 22, 23. So it was regional, but usually the flood is very local. Or if you have a flood from a big river like the Po River, it becomes a regional flood, but usually they are very local. Droughts are much more extended because droughts usually are extended to over a continent. And the duration is different. Drought may last for years. Both of them have a significant impact on ecosystems and human communities, and recovery may take a long time. Keep in mind that they may impact also groundwater, and recovering groundwater may take a long time, is a complicated process. and may have significant health implication, and may also cause disruption of critical infrastructures like power networks, etc. And very often, these, especially the floods, which develop in a short time frame, call us by surprise. And this is astonishing because it's still amazing. What is the reason why we are still got by surprise by floods? We have meteorological prediction. In the Romagna region, the precipitation, the extreme precipitation was predicted 48 hours in advance. The red warning was issued 2 days earlier. Still, we were got by surprise. And this is something that needs to be investigated, we have to understand the reasons. It's lack of preparation. It's the fact that we are not prepared, or it's the fact that something is happening that we don't know, like why we were not able to predict that 22 rivers could overflow. I mean, it's really, so maybe that there is also land use change that is contributing, that something that makes us unaware of possible causes. And the fact also that the critical infrastructures are disrupted. This is, I mean, something that it's hard to believe. So the flood that occurred in Germany in 2021, they lost the power in the hospital, and the hospital was inundated. They had to evacuate the patients by hands because they couldn't use the elevators. I mean, it is something that in a country that should be prepared, still they get us, they call us by surprise. Hurricanes, it's a matter that is frequently discussed. Is climate change impacting over the dynamics of hurricanes? And climate models say yes. And also IPCC, okay, I'll tell you in a moment what is IPCC, International Intergovernmental Panel on Climate Change. I'll tell you in a second. IPCC says that globally, there is low confidence in attribution of changes in tropical cyclone activity to human influence. This is due to insufficient observational evidence, lack of physical understanding of the links between anthropogenic drivers of climate and the tropical cyclone activity, and the low level of agreement between studies as to the relative importance of natural variability and man-made is an old term, okay? We should say human-made now, forcing, not just now. We should have said human-made even earlier. So forgive, this is a quote, but still I think we should correct it. Hurricanes have a substantial impact on the human health for the same reasons as floods. Let me just reflect a little bit on the statement from IPCC. IPCC, as we will see, it's the international authority for the study of climate change. IPCC responds to governments. When IPCC recognizes that there is still a lack of understanding, it means that there is no doubt, it's not the voice of the skeptics. You know, climate skeptics basically tend to attribute climate change more to humans than, more to natural variability than to humans. IPCC is for sure not skeptic, but they still recognize that here for hurricanes, there is still a lack of understanding. This is very significant. The opinion of NASA instead is different. They say climate models predict hurricanes will likely cause more intense rainfall and have an increased coastal flood risk. So just to let you know that when we talk about the science of climate, you know, there is still a lot of unknowns. And this doesn't mean that the science is unreliable. It only means that for some details, the science is still not settled, which is not a negative thing. We know that science is evolving and there are scientific questions that are unsolved, that they are not settled. Climate is part of it. Why I'm saying this? Because I think it is extremely dangerous if people assume that we can predict climate in a precise way. This is extremely dangerous. And I give you an example. When the flood in Tuscany occurred in, I think it was in September, October. Yeah, September, October, something like that, last year. The Civil Protection issued an orange warning for extreme precipitation. It's not the highest level of warning. The highest is red. But orange, if you look at the description, at the details of the Civil Protection, means that it's not excluded that you get a flood. It may happen. Orange means that there is some uncertainty. After the flood, some people claimed that this was a mistake because the Civil Protection should have issued a red warning. It means that it was not understood by the public and the administrations what is a warning, what is the uncertainty of a warning. So we shouldn't assume, if people get convinced that everything is precise, if they see an orange warning, they don't pay attention. This is extremely dangerous. So uncertainty, of course, with I would say with some conservative actions, should be communicated. Why I say conservative? Because it depends on what is the recipient, on who is the recipient of your message. So of course, uncertainty should be vehiculated in its full description to authorities. To the public, you have to be a little bit more careful because uncertainty can be misunderstood. So you have to be sure that when you communicate something, it is understood by the recipient of the message. But negating uncertainty, neglecting uncertainty is a mistake. This is why IPCC is attributing a level of uncertainty, a level of confidence to any of its statement. Okay. I think we have time to discuss one more slide, or one, maybe two. Negative impacts of climate change, sea level rise. Okay, so we already said that global average sea level has risen between 8 and 9 inches, about 20 centimeters, 2024, since 1880. In 2021, global sea level set a new record high, 97 millimeters, which means above 1993 levels. From the beginning of the 90s of the past century, there has been an increase of the rate of annual sea level rise. Actually, the rate of global sea level rise is, as I said, accelerating. It has more than doubled from 2006 to 2015. So now we are about 3.6 millimeters per year of sea level rise. In many locations, the rate of local sea level rise is greater. As I mentioned to you, it's not homogeneous, due to also to land processes, because subsidence is also having an increase on the extension of the area that is inundated by water. And high tide flooding is now 300% more than, from 300% to 900% more frequent than it was 50 years ago. And sea level rise has several negative effects. I want to mention one effect that is often not considered, which is very relevant even for small increase of sea level, is the salination, of coastal waters, because the salt water intrudes into the land, and the depth of this intrusion is large and increases a lot even with a small increase of sea level. So even if you have an increase of sea level of only 5 centimeters, the depth, the distance to which the salt water intrudes into the land increases a lot. So it's very amplified. And what is the consequence of this? Of course, impact on the ecosystems and impact on groundwater quality, because it may happen that the wells from which we extract groundwater, ground fresh water, get salted. And so it's not usable anymore. And of course, you have also an impact on the ecosystem, on vegetation, etc. And this is an impact, as I said, that is frequently forgotten, and it's indeed very important. And this is something that is largely studied by researchers, how to mitigate saltwater intrusion. It's another impact, negative impact of climate change. But, and we close with this slide, we also have positive impacts of climate change, which are frequently not communicated. Let me start from a premise. We had in the past changes in climate that were indeed much relevant. I mean, we had glaciations, we had periods without ice caps. There were no humans, but still during the humans' time span over the Earth, there were climate changes that were very significant, much larger than those that we are experiencing now. What is the problem? I mean, it's clear that if you have a change in climate, you have positive and negative impacts. You have to expect that because, for instance, if you get lands that are now frozen, that get without snow, without ice, of course, these lands can be cultivated, which means that it's an opportunity. It's a positive impact. You have also negative impacts. And what is the problem? The problem is, and the history of humans confirms this, if you have a climate change, this stimulates migration. To survive, people need to migrate, because in the south, you have lands that were arable, were producing foods, like the Sahara Desert. We know that it was probably a forest a lot of time ago, which cannot be used anymore. And people have to move towards lands that becomes now more usable in terms of producing food, in terms of living. So migration is the natural way to react. And in fact, we know that in the prehistory, there were long-term migrations from which humans from Australia, they moved to Europe and moved everywhere. The problem is that these migrations trigger social tensions and trigger wars, because of course you get in fight with the people living in the lands where you want to go to live. And this is something that is happening already today. We know that. It is not only stimulated by climate change, but climate change is a component of that. So if it is taking place in a long time, the socioeconomic system has the time to adapt to it. If it takes place in a very short time, this change, then it means wars, it means conflicts and etc. So what are the positive impact? Less mortality for cold waves, for instance. And you may say, okay, but what about hot waves? Actually, there are studies who prove that the prosperity of human society was larger in warmer periods than in cold periods, because the mortality from cold waves is more risky with respect to mortality from hot waves. decreased avalanche risk in some regions, and positive effect on farming in some regions because you have a longer season for cultivating crops. And you know, carbon dioxide is a fertilizer. Some crops grow better in the presence of higher carbon dioxide levels. Tourism may benefit from a longer season, but not skiing. And shipping commerce may benefit from the possible opening of the Northwest Passage, and the North region may benefit from an expansion of agriculture. So we have to be aware of also the positive effect, because if we want to know a phenomena, a process, we have to know everything. We cannot get a biased knowledge, okay? Quality of wine is becoming better in some regions, not in all of them. In some regions, for instance, the French wine, the latest year, it has benefited a lot from, okay, this is not very significant unless you like me drinking some wine. Okay, any questions so far? No question. This is not a right sign. Let me see your faces. Okay, in any case, if you have any question, you can write to me. Otherwise, let me stop the recording, and otherwise, okay, and